1.6 here, we are looking at inequalities, and we have that new notation to look at now, so we're discussing unions. A union looks like this. It excludes numbers, not included, not intersected on, they're outside, they're not in between. So something like this, for example, we know what we can plug in there, right? Any number that is greater than 3 would work. So like I could plug in a 4, a 5, a 6, a 7. But I could also plug in a -4 or a -5 or a -6 or a -7, because when you take the absolute value of those, they all become positive, which make them work. So what that means is anything less than a -3 would work, like -4, -5, -6, -7. And anything greater than 3, like 4, 5, 6, and 7 would work. So what that means is all of those work except what's in the middle. So we're basically jumping, and you can think of this as a jump, right? All the numbers from -infinity work till it gets to -3, and it doesn't touch -3 till it gets to it. Then we skip over it, and we join up again right at 3, but we're not touching 3, and we go the whole way up to infinity. So that's how you'd write that. It's not including the middle, it's excluding those numbers.
Am I right or am I right?
Intersection looks like that, and it's what's in between the numbers, it's what overlaps the numbers. So here's the basic example I can give with this one, with the numbers. Where are they at here? -infinity to 3 means it's all those numbers from -infinity, and it goes the whole way up until 3. -infinity to, or -3 to infinity means it goes from -infinity the whole way up the ladder to positive infinity. So intersection is wherever they overlap, and they overlap in between this area of 3 and -3. So how do you rewrite that? Well, it touches, it doesn't touch, it's right at -3 and it's right at 3. It's where they both overlap each other, right? From here to here, from we have from -infinity the whole way to 3, and from -3 to infinity. So it overlaps in between there, and because they're open holes, they don't touch it. That's why it's those curved brackets right there. Quadratic inequalities in one variables is a way to solve quadratic inequalities by factoring and graphing. Okay, quadratic inequalities are a little different. So the graph's here for a simple reason. Very, very simple reason. Not for anything accurate. Okay, so the graph is just here, and you don't need necessarily a graph to solve these, but it's there to help you figure out how to graph it. So what we're saying is, first, factor this. Okay, so when I factor it, you think of numbers that multiply to give you 5, that add to give you -6. Well, I can, right? -1 and -5. So I separate this as x minus 1 and x minus 5. So when I go to solve this, I get a +1 and a +5 as my answer. So what I'm going to do basically here is at 1 and at 5, I'm going to put a point. Because this is a positive, right? We know that positive quadratics go up in that fashion. So there it is. It's just a rough graph. Okay. So here's what the problem is asking. Where is all of this less than 0? Where is it less than 0? Well, this line right here, this line on the axis stands for 0. So where is it less than 0? Well, it's less than 0 down here, right? All this is less than 0. That's where the graph is less than 0. This is above 0. This is above 0. This is all below 0. So it's below 0 in between 1 and 5. The reason why it's less than signs is because this is a less than sign. It's not including the point. That's why they're less than signs. So taking a look at this one, we factor. And to factor that, can't factor it, so we're going to have to do the quadratic equation. So this is to show you how you can still solve it with quadratic and still graph it to get your answer. So b happens to be 3, so that's why I put 3's in there. A happens to be a 2, and -3 happens to be c. So that's a -3, 9 minus 4 times 2 times -3 is 33, divided by 4. So you get about 0.69 and -2.19. So 0.69 we'll say is right there, and 2.19 is right there. This once again is positive, so it goes up like this. And I drew a solid line because this has a bar underneath it, which means it includes those points. So when is it greater than 0? Right here, right? Because this is the line at 0. Over here it's greater than 0. Over here it's greater than 0. So where's it greater than 0 at? From infinity, this negative infinity, until it gets to negative 2.19. And then from 0.69 to infinity.
You're gonna end up eating a steady diet of government cheese and living in a van down by the river.
So to factor this, I have to get everything onto one side. So that's what I'm doing. X squared plus 2x minus 8 is less than or equal to 0. Can I factor it? This can be factored. So what multiplies to give you negative 8? That adds to give you 2. 4 and negative 2. So I have x plus 4 and x minus 2. So when I separate it, I would get negative 4 is my answer and positive 2. Right? Because I just minus 4 on both sides, add 2 to both sides. So I put them down here, negative 4 and positive 2. This is x squared, so positive means it goes up. So there it is going up. It has less than or equal to, so I drew a solid line there, meaning it includes all those points. So where is it less than 0? Down here, in between those 2 points. So in between negative 4 and 2 is your answer. So if you wanted to, it would be bracket, bracket, if you wanted to write it, our new notation. Example 7. Let's get everything onto one side. So I'm going to add a 3x squared because, like I said, I like to make sure I have positive x squareds there. So I flip it because, remember, we always have our inequalities with it on the right-hand side. And that's how this works. We've got to make sure that the inequalities are on the right-hand side when we do this. So let's see if we can factor that. I take a 3 out of everything. That leaves me with an x squared minus 7x plus 10. Can you think of two numbers that multiply to give you 10, that add to give you a negative 7? Yep, negative 2 and negative 5, because negative 2 times negative 5 is 10. Negative 2 plus negative 5 is negative 7. So you end up getting x plus 2 and x plus 5. So when you go to think of it to set up an interval, you can also try to solve it with these intervals. I don't think this way works out as nice. But if you were to graph this, I would say, hey, the graph comes and looks like this. It's going up. So where is it greater than 0? On the outsides. So this is just a checklist to show you, hey, it works on the outsides. So we put it on the outsides. And remember, it's like I said, it goes on the outsides because that's why I told you to do the graphs. It goes up. Where is it greater than 0? On the ends, not underneath it, on the ends. So that's why I know it goes from negative infinity till it gets to 2. Then it goes from 5 till it gets to infinity. And this is like what we're skipping. We're leaping over it.
Isn't she gorgeous?
So when we come back here, we'll try to finish up the inequalities if that's possible. And talk to you in a little bit.